Thank you. Good evening and welcome. This is going to be probably a little less formal than most of the recitals. What I'm going to do is talk about my dissertation project and play two different pieces over the course of the evening. The dissertation is called Interactive Musical Partner, a System for Human-Computer Duo Improvisations. Its nickname is IMP, partly because all computer music projects need acronyms for names, and also because it's much easier to say, IMP. And the name actually is important in terms of what I wanted the program to be able to do. I wanted it to be interactive, in that there was actually two-way communication between the human and the computer. And the method of this communication, to borrow a term from George Lewis, who in the free jazz trombone playing computer music world's sort of a big deal, he uses the term dialogic communication, meaning that it's a dialogue between the performer and the computer, and that dialogue happens through sound. So the interactions aren't that I reach down and touch a button to tell the computer what to do, or that I get some sort of tactile feedback back from the computer. The computer influences my actions through the sounds it makes, and I influence the computer's actions through the sounds I make. And also interactive recently has been quite a buzzword in the computer music world. You often see at conferences pieces listed for clarinet and interactive computer. And often those things tend to sound reactive more than interactive. So an important part of the idea of interactivity is that the program has some agency, that it's able to make decisions or introduce new musical material on its own, that it's not necessarily completely dependent upon what I do for the ways that it interacts, but it's an equal partner. I wanted it to be musical. It should be musical both to listen to and interact with. Now there's a pretty specific aesthetic space that I've decided to use. So the interpretation of musical might be a bit up to the listener. But I want it to behave in a musical way similar to the way humans interact in similar aesthetic spaces. And then I wanted it to be a partner, to have equal responsibility with the human improviser, in that it could introduce material as much as I could introduce material. It could decide to play along with what I do, I could decide to play along with what it does. That all of these are possibilities. In the process of working on or conceptualizing this early on, I had a conversation with George Lewis, and we're talking about the agency of the computer. That it's important that it be able to play. If you just turn it on and leave it alone and you never play, that the computer be able to play something. And then George said something that struck me as quite profound at the time. He said, well, it's important that it makes music that you like. So the partner part comes in that we should each make music that we like. So some of the early goals or early decisions that were made in this research was that it would be a free improvisation aesthetic. There's a lot, well, I don't want to say a lot, there are numerous programs out there that behave in manners that appear to be improvisation in pretty specific straight-ahead jazz settings. There's robots that play over Coltrane changes, and those rules are fairly, I don't want to say easy to write, but it's been done. David Cope's gotten a computer to write things that sound just like Bach. And so I decided that I wanted to go with a free improvisation aesthetic for this. And part of the definition of that aesthetic is kind of anything goes. Derek Bailey used the term non-idiomatic improvisation, meaning that it doesn't necessarily follow the rules of flamenco or jazz or Indian improvised music, but that all of those things might be on the table. So it's a free improvisation aesthetic. I decided early on that it would be a duo setting, one voice for the human and one voice for the computer. This differs from some of the other programs out there that do similar things. For instance, George Lewis's Voyager program is a 64-voice thing. It's a very almost orchestral type sound. It's big and makes has a lot of different textures going on. I decided to do a duo setting, partially to differentiate from some of the things that have been done, but also because that's the setting when interacting with human improvisers that I find the most rewarding. I find we can really learn a lot about ourselves as improvisers in that duo context where you're really just dealing with one other voice and you can interact in a very personal way and have those musical negotiations, so to speak. So I wanted it to be a duo setting. And I also wanted to have somewhat variable behavior patterns or personality. I wanted to make something that wouldn't necessarily do the same thing every time it performed. And I wanted to be able to address timbral information. I believe, especially as a trombonist, that when I play in freely improvised settings, timbral information is a large part of the musical content. And that the ability to read timbre and change timbre in an interactive manner with your partner is important. And that's where a lot of the music happens once we get beyond notes and rhythms, so to speak, once we get into more textural types of improvisation. Now, I used the word personality a second ago, so I have to put a little disclaimer here that deals with personification, intention, and meaning. I'm going to talk about imp like it is a person. I'm going to personify imp. That is done purely for ease of communication. I know it's not a person. It doesn't have meaning or create intention. A summary of the Husserl idea on intentionality. The intentional content of an intentional event is the way in which the subject thinks about or presents herself to the intentional object. That's a nice philosophy textbook quote there for you. My point is, imp does not think about the intentional object. Imp does not present herself. Imp simply follows the algorithm that I programmed into it. I think I create some intention, or whoever plays with imp creates intention. So there is intention and meaning present here, but it doesn't come from the computer. And our philosopher friends have spilled a lot of ink talking about this. And pretty much the ones that I tend to agree with come to the conclusion that the computer does not improvise, that intention is a required part of improvisation. So I'm going to use terms that make it sound like the computer's improvising, that I'm personifying the computer. I just want to put this disclaimer. That's for ease of communication only. I want to make clear that I don't think the computer is creating any sort of intention. So, as I started to think about this project, I came up with some problems that would need to be solved for it to come to fruition. Dry mouth was not one of them. First, I would have to decide on some parameters for the musical personality settings, or what I'll abbreviate as MPS, coming up. These would be the things that would allow it to behave differently each time, to have its own sort of variable personality. I would have to map these parameters to extractable audio features, find things that it could hear in the human improviser, and map those to how, make the connections to how it would affect those MPS. I would have to come up with a system for musical decision-making, or a generative algorithm, the way in which imp could create its side of the equation. And then I would have to figure out how to make the sounds, or have a synthesis module that allowed itself to be connected to these other parameters that would work in this system. So, the first thing I did was a piece that was sort of an etude. It was called Peter's Mountain, for improviser and computer. And I composed it in 2011 really as an etude for working on the generative algorithm, or working out some ideas in the generative algorithm. So, Peter's Mountain was done in Max for Live. It's got two voices from the computer. And much of the way I put together the generative algorithm for Peter's Mountain got carried over into imp. There's an important distinction here in that Peter's Mountain is not interactive in any way. It is, sorry. It's not, also not supposed to start. It's not interactive. It does what it does. Every time it plays, it generates a different set of musical sounds, although they have some similarities. Over the course of the 6 minutes or so, the map of the densities is pretty similar. The general types of intervals it plays at different times in the piece are similar. The types of sounds, the timbres of the sounds as they change, do so in the same time scale each time, although the actual specific content of rhythms or notes will be different each time. So what I'm going to do now is I'm going to play Peter's Mountain for you. And listen to this, realizing that I am the only one reacting here. The computer is simply doing what it's going to do. It's not listening to me. And hopefully, in a little bit when I play with him, the difference will be obvious. So, this is Peter's Mountain. Give me just a moment. So that's Peter's Mountain, and that was the etude that preceded Imp. So much of the research in Imp had to do with finding the musical personality settings, sorting out these parameters and finding ways to connect them to musical features. The density of event setting, which goes from 0 to 127, all of these scale 0 to 127 sort of by default of how the sliders work, and they get scaled in other places. But this end, if it's all the way here, every event that comes up will make sound. And if it's all the way on less dense, if it's on 0, none of the events that come up will make sound. So there's a module in the program, which we'll see when we look at the synthesis module, that's called the density decider. So each time an event comes up, based on this setting, a weighted decision is made as to whether or not that event makes sound. So the rhythmic context, or the rhythmic content stays the same. They just happen to be notes or rests, to use notational parlance. Length of events and rhythmic regularity work together. Length of events is essentially speed. I tried to, all of the conception behind Imp was to use as little abstraction as possible, to try not to think of things in terms of notes and metered rhythms, but to think of things in terms of frequencies and durations. So all of the calculations are done in terms of hertz or milliseconds. Length of events, well, rhythmic regularity sets up a pool of ratios of note lengths. If it's set all the way on the irregular end, they're very different. And if you set it all the way to the regular end, there's only one ratio. And then the length of event setting is a factor by which these are multiplied to make it feel faster or slower. And these are both influenced by input from the human. The regularity of input from the human affects how those change. There are two settings for listenerness. One is frequency listenerness and one is duration listenerness. And those deal with how much imp listens to the human improviser. On this end, all content from listening means that every frequency that imp plays back would be a frequency that it heard from the human. And at the other end, everything would be a frequency that it got from its own generative algorithm. Same thing with duration. Melodicness sets up the general pitch content of the material generated by imp. All the way on the melodic end, it makes things in pentatonic scales. It moves through a range of major scales, melodic minor scales, diminished whole tone, to fully chromatic on the abstract end. And all of the different keys are in there. And then there's this variation setting, which controls an algorithm that varies all of these other settings over the course of the performance. So these settings can, some of them move depending on what imp hears, others of them move just based on this variation setting. So for example, the melodicness, it won't stay on the same pentatonic scale the whole time. The variation setting will cause that to move. There is a timer here. You can set the amount of time that the episode lasts. Ending an improvisation, even with really sensitive musical humans, is a difficult thing to do. Communicating when to end the improvisation with the computer is an area for further research. So there's a timer. I tell it this episode is going to last 8.5 minutes or whatever. And at that point in time, a process of ending, it starts a process of ending, which gradually decreases the density and allows it to fade out. So the available textures in an ending are not the same as they would be between two humans, but it does allow the episodes to end in a musical manner. And so that's what's here on the MPS. Now, the synthesis module, imp makes its sounds via FM synthesis. I tried several synthesis methods before deciding on FM, and I must say the influence of one of my professors was a large part of it becoming FM when he said, no, you should do FM. So I said, yes, sir, I'll do FM. And actually, it ended up working out very well and mapping very well to the timbral controls that I'm going to talk about in a minute. I performed this piece, I guess, a week and a half ago in California, and one of the questions that I was asked at dinner afterwards was, why does it sound like this? Why'd you use that FM synth sound? Because it sounds very much like a computer. And I said, because I want it to sound like a computer. I don't want the human to be able to forget that they're improvising with a computer. If I were going to try to make it completely like a human, it would be much easier to call one of the many great human improvisers and play with them. The fact that you're interacting with a computer in this type of fashion is part of the thing. It's part of what reveals things about me as an improviser, what reveals things about you as a listener. So I didn't want that to be forgettable. So that's why it sounds very much like a computer, and that's intentional. There's a envelope here that's a simple attack decay envelope, or attack release envelope rather. And that changes length with the various, with the different durations. This is the density decider, so whenever an event ends, a bang is sent out, and so it decides if the next event will sound or not sound. And the other portion, there's actually two FM modules here. There's the first order FM, which is at a harmonicity ratio of 2, meaning that the modulator is twice whatever the carrier frequency is. And then as the timbre changes, there's a second order modulator that gets multiplied in. And this gain changes depending on some of the timbral settings. And if it gets into the really crunchy mode, it will also change the harmonicity setting. So it can go from a pretty pure bell-like FM synthesis sound to some fairly crunchy sort of things, depending upon what it gets from the human improviser. Timbre was one of my goals at the beginning, and a machine learning algorithm was used to take the audio features and have them influence timbre. The Wackenator is the program that I used to do this. It was written by Rebecca Fiedbrink, who has visited here and shown it to us. And it uses a neural network to take brightness, noisiness, and loudness features from the listener module in the program and turns them into one parameter that I call timbral noise. If I were being less formal, I'd probably just call it crunchiness. And it listens, so it takes those settings as it has learned them from some training that I did. So I had solo trombone recordings, and I coded them, and I said, okay, this is a very pure sound, this is a very crunchy sound, and gave it lots of examples. And then the Wekinator trains the neural network to give out numbers that get scaled to make that happen. My original thought was that I would be able to use a couple of different instrumental recordings and use it for everyone. So I did the first set of training data I used were some solo saxophone recordings and solo trombone recordings. And I found that when I tested it with other instruments, with flutists or different voice saxophones, alto saxophone as opposed to tenor saxophone, that it didn't behave as well. So when I perform with it tonight, I'm using a set of training data that's taken all from trombone sounds. And ideally, I think at this point, different training data for each different instrument would yield the best results in terms of the timbre system. So the way the neural network works is, this is a generic neural network diagram. It takes the inputs, in this case I only have 3, and they're brightness, noisiness, and loudness, and correlates them in a hidden layer and gives one single output. So that single output, again, affects the gain of this second order modulator, and eventually might affect the harmonicity ratio of the first order as well. And hopefully as I play it, you'll hear those things change, although you won't be able to see what it's actually doing. So now comes the fun part. We get to play with imp. So this microphone is not coming out of the speaker, it's simply the way in which imp hears me. Get my personality setting set, there we go. thank you very much. Does anybody have any questions? If you want to hear all the real technical ones, 3 o'clock tomorrow in room 102. Anyone? Bueller?
I have questions for tomorrow.
Okay, good. I look forward to them. Okay, great. Thank you very much.